Today, we're going to talk about a little bit more specifically about what makes up a quantity. And we're going to focus in on one specific area, and that is units of a particular problem. All quantities that we're going to study in physics have several different components to them, and just about every one of them has four parts. The value, which should be the number itself. The units, things like meters or inches or feet or meters per second or pounds. A lot of quantities have direction associated with them. Those would be things that you might consider calling it a vector, but something could be 10 pounds to the left or to the right. You could have velocity. You could be traveling west versus east versus north versus up or down, or some combination of those. And finally, all quantities have some element of uncertainty to them. That is that we can't know them 100%. There's always a little bit of uncertainty in how accurate or precise a measurement can be. So today we're going to focus specifically on units. Now, just about every quantity requires some sort of a unit, and we need to, in this particular class, write them. They should always be written. If you just have a specific phrase like a length of 43.2, period, that doesn't mean anything. 43.2 what? 43.2 junior hires? 43.2 feet, inches, 43.2 meters per second, which wouldn't be a length anymore. That would be a speed. You've got to write units if a unit is implied. Now, in this class, we're going to study primarily two systems of units. Mostly, we're going to talk about the metric system. The metric system is, as its name implies, things based off of measuring length in meters. And you've probably heard of centimeters and kilometers. Those are all metric units. And the base unit of that is a meter. Mass in that system is measured in kilograms, whereas we in America have grown up using the English system, which is kind of a misnomer because England doesn't use the English system anymore. They've used the metric system. But these would be things like feet and inches and yards and miles. And we measure our forces and our weights, for instance, in pounds as opposed to kilograms. So we will use the English system some, but science as a whole uses the metric system, and we'll be doing a lot of that as well to get you more familiar. So while we're talking about the metric system, let me begin by just describing some of its merits. What are some of the reasons why the metric system is so popular? In fact, it's not a popularity contest. It is the standard in the science field. Probably the main reason is that it is a universal standard. All scientists use the metric system. That's our system. And so you've got to think back to the 16 and 1700s. At the time, measuring a foot was, as its name implies, using your feet. And some people have really big feet, and some people have really small feet. So whose foot is the standard? So scientists of the day decided we needed a standard, and so they measured something and they called it the meter. And everybody uses that now. Another merit of the metric system is that it is an interconnected system, which means the quantities involved are defined in relationship to other quantities. The best example I can give you right now, without going into too much more detail, is a gram. For instance, is not just some arbitrary measurement. It is specifically the weight of a cubic centimeter of water. Another merit of the metric system is that it is a decimal system, meaning everything is based off of the number 10. The English system is not, and so you get ridiculous things like 5,280 feet in a mile, and 12 inches in a foot, and just lots of different things that you kind of have memorized that don't necessarily mean a whole lot. Whereas in the metric system, it's all based on 10. Now, we could have used other systems, and in fact, when they derived the metric system, they considered using a binary system, which would be base 2, which probably would have been smart nowadays, since everything's based on computers, so that would be a really easy system to use. But the duodecimal system, where everything was based off of 12, that makes sense because we had 12 hours in a day and so forth, so maybe continuing that to everything else. The sexagesimal system is everything's based off of 60. You might think, why that system? Well, primarily because it's dividable by so many things. You can divide 60 in half, you can divide it in thirds and fourths and fifths and sixths, and all of those would produce nice numbers. You wouldn't have to worry about decimals or fractions or things like that. The fourth main reason for using the metric system is that each of the different quantities can use the exact same prefixes, which are all based on the power of 10. You've probably learned many of these, centa or milli or micrometer or kilometer, megameter, but all those things can also be applied to, say, watts. You can have a kilowatt or a megawatt or a as in my favorite movie, Back to the Future, you can have 1.21 gigawatts of energy or power. And each of those prefixes stands for a specific power of 10. Mega means a million, or 10 to the 6th power. Kilo, like a kilometer, is 1,000 meters. That's 10 to the 3rd. A centimeter is actually smaller than a meter. It's 100th. So cents, just like a cent is 100th of a dollar, a centimeter is 100th, or 10 to the negative 2nd power. A milli, you probably recognize a millipede is something that has 1,000 legs, but actually milli is a thousandth. So a millimeter is 1,000th of a meter. That's 10 to the negative 3rd. And a micrometer is something that is 10 to the negative 6th, or a millionth of a meter. Those things are now so small that we can't see them without the use of a microscope. So, anyway. Now, how do we deal with units? The overarching rule that will apply throughout the year is that we treat units just like they are variables. So if you can do math with 2x plus 5x equals 7x, you do this exact same thing with meters. You can only add or subtract quantities if they have the same unit. So you can add, say, you can add 3 feet and 8 feet together, and you get 11 feet. And you can do 2 meters minus 1 meter to get 1 meter. When you've got multiplication or division, the units combine, and or sometimes they cancel out and they create new units. For instance, if you've got a distance of 3 feet and you multiply that by another distance of 8 feet, the 3 and the 8 combine to give you 24, and feet times feet combine to give us a new unit called a square foot. And now we have a totally new quantity. These were both distances, and now we've got an area. When you divide, the units stick around, and so often you will divide a distance like 3 feet by a time, say 1.5 seconds. And you take the numbers and divide them to get 2, and the units just kind of stick around and combine to create this new unit, feet per second, which is a type of velocity unit or speed unit. Finally, we can convert between units by using conversion factors.